Today we are going to be talking about tRNA and its function and translation of mRNA. To start off, we are going to define Francis Crick's adapter hypothesis, which describes tRNA. In his adapter hypothesis, Crick proposed that small RNA molecules would be the adapters that could be charged with amino acids by specific enzymes and could identify the codons of the mRNA by base pairing. The small RNA molecules Crick is talking about are now known as tRNA. Now, calling tRNA an adapter is accurate to its function. Here is a closer look at the actual structure of tRNA. The loop at the lowest point is the adapter part of the molecule. This is where the anticodon is present that matches up to the mRNA codon. This part of the molecule is the adapter part. That is because the anticodon can match up to, or adapt to the mRNA codon. A single strand of mRNA binds to a ribosome, which is made up of proteins and rRNA. Within the ribosome, there are three tRNA binding sites, which are P, A, and E. The P site is where the tRNA with the amino acid attached binds. The A site is where the tRNA attached to the growing polypeptide chain binds, and the E site is where the tRNA exits the ribosome. Through this process, the tRNA has the anticodon location that is different for each tRNA molecule, so it can match up to an mRNA codon. And for each codon, the tRNA is able to bind and bring the necessary amino acids to the ribosome for the polypeptide chain. This is why the label adapter is accurate for the tRNA molecule. Now, an alteration that prevents the tRNA from acting as an adapter molecule could be preventing the tRNA from being charged. If the alteration causes a malfunction to the amino acid attachment site to prevent binding, then tRNA would be considered uncharged and would not bind to the P or A site in a ribosome. In this picture, I made the alteration visible by a jagged line representing the altered amino acid attachment site versus a smooth line as the wild type. The only place in a ribosome you can find an uncharged tRNA is the E site when the molecule is leaving after having added its amino acid to the polypeptide chain. This prevents the tRNA from being an adapter because if it can't bind to the ribosome, then that makes the anticodon of the tRNA useless as an adapter. And without the ability to bind to amino acids, the molecule has no purpose whatsoever. This list shows my sources for the pictures I've used and where I gained this information from, and these will also be posted in the description below. Thank you for watching, and I hope you enjoyed my video.